Hello and welcome, folks, to Advent of Code 2023, Day 8. So things are moving along quite smoothly now. It seems the difficulty, those first few kind of very difficult odd days, haven't carried through so far. We're kind of back to what I would say is sort of the normal difficulty level at this early stage of Advent of Code. So that's cool. We had Day eight's puzzle today, and it was quite nice. There was sort of one little mental leap that you might have needed to make to solve the second part. Assuming you did make that leap, it was a pretty straightforward problem to solve, but making that leap may have just kind of, it may not have occurred to certain people, just a quick way that you could get around having to do a lot of computations. So with that said, let's jump in and have a look at the problem and have a look at some code. So day 8, Haunted Wasteland. So we're still riding our camel across the desert. There's a sandstorm that's quickly approaching. You turn to your elf and she disappears before your eyes. But it says that she was just warning you about ghosts a minute ago. So God knows what happened there, but I hope that poor elf is okay. So you look through the different pouches the camel has and you find maps. So the maps basically contain this list of like sort of nodes, like a network thing, and instructions on like how to navigate that network. So you assume that basically you need to tell your camel that you need to guide your camel along this path and that should be a path to safety or something like that. So they give you this input here. So it's quite obvious from looking at it exactly what it is. It's basically like like a binary tree. So you have a node, and then you've got a left and a right node. And so as you traverse this tree, at each node that you go down, you have a choice. You can go left or you can go right, and that's it. So immediately, my instinct went to this is going to be something like a shortest paths type scenario, trying to solve something like that. You know, you might have to do stuff like tree rotations or things like that. Turns out not to be quite that case. I'm sure maybe you could use those approaches to solve this problem. I'm not certain. I didn't, but turned out not to really be necessary anyway. So the only other thing they give you is they give you this thing at the top. So or L in this case, and what this is telling you is this tells you, like, in a loop, how you're supposed to walk through this map. So you start on the first node, and or is your first instruction. So that means you go to the right. Then once you're on that node, to walk to the next node, you look at the next instruction, which is L. So you go L, you go to the left, and then you go back around to the start again. So it's or L, and then that's or L, or L, or L the whole way along. So it's basically this looping pattern of instructions, and it could be as long or as short as it's arbitrary. So in the real input, it's very, very long. I think it's I don't know. It looks to be the real input. It looks to be maybe 20 or 30 characters long, something like that. But anyway, yeah, it's quite long. In the real input. But ultimately, it doesn't matter how long it is. Once you reach the end of it, you just loop back around to the very start and just keep going in a loop. Yeah, and that's it. That's it, really. You're told that this is how you walk through this map. And the puzzle, what you're trying to solve, is basically when you get to the end of the map, how many steps it took you to get to the end of the map. We're told that our starting point is AAA, and that our finishing point is ZZZ, and that's it. So we just need to try and solve for that length until we get there, until we get to the bottom. So yeah, it's not terribly complicated, but let's have a look at some code and see how I implement it. So yeah, part 1. So first thing we need to do, we set up some variables up here. We're going to need to know how many like the list of all the instructions, which is the left rights, and then we're also going to need to just store a count of how many there are. That's just slight efficiency saving, storing the count, and then we need to have the map basically stored as well. So I've chosen to store that as a hash dictionary type thing. That it works quite nicely because you can just store the key of each node, and then inside the so the value then for each dictionary entry is going to be the left and the right, which references another key. So walking the tree is like an order 1 operation because you just jump to the node each time based on the index. So yeah, the thing then we need to do is we have to set up. So we'll just loop through our input file and set up the values. So the first index, first line, we'll pull out all those instructions, store the count of them, and then every other line we'll just skip the next blank line, and then we'll just basically storing the node values. So we take our map, we pull out the key, we store the left and the right values, and that's it. Just some little substitution line parsing logic. So then, yeah, this down here, the next loop is the real meat of it. So this is where we actually are going to walk this tree and get the number of steps out. Very simple algorithm. We know we start at A. So that's our next node that we're going to. First node, next node, same thing. And we'll start our steps at 0. So we're going to keep doing this loop until the next node is the ZZZ node. So what we do, so we're going to basically, all the loop's going to do is it's just going to find the next node each time, find the next node that we should be going to each time. And if that's Z, then we'll break and that'll be it, and we'll just get the steps at the end of it. But to determine the next node, we need to do 2 things. So the first thing we need to do is we need to figure out, well, should I be going left or right, which is based on the instruction set that we got earlier. So in here we have our instruction set, which is an array, and we're indexing that based on the step that we're currently on mod the instruction count number. So this might not be immediately obvious if you're not seen this like modulo arithmetic stuff before, but basically when you mod a number with another number, you'll always get an output that's in the range of the first number, basically. Of the second number. So if this instruction, so if there's 10 instructions, or say 5 instructions, any number mod 5 will always give you a number between 0 and 5, basically. So that does seems unintuitive, but that's how it works, because it's always the remainder of a division, basically. So if you do this, that will effectively give you a looping thing. So no matter what value steps gets up to, so steps will continue counting one after the other, and the mod will always give you that window that will then apply to what instruction you're at. So it gives you that circular loop thing. That's a trick that showed up in, I think I've used this almost every year in Advent of Code for something. There almost always seems to be a revolving pattern, and this mod thing always really helps with that. So that's all it is. You don't have to use this. You could use something like just a counter that then, once it reaches a limit, just resets itself. But this just means it's just one line of just simple maths that does it, the whole thing. So yeah, that will then always return either an or an L out of this array. So we check that. If it's L, we go to the left node. If it's or, we go to the right node. That's it, really. So that just sets the next node value. We increment the step counter. And yeah, we just do that in a loop until we encounter ZZZ, and that's it. That's the end. That's our answer then. So that just dumps out the steps at the end that it took. So this is pretty fast on the sample anyway. Yeah, very, very fast. -5 again. And the answer is 2. I think, does it give us is there a second sample that it gave us on that? Yeah, which the answer is 6. It's also very fast. So then we can put in our input, and that is the right answer, and still pretty fast, 5 milliseconds. So that's pretty good. Yeah, so not a huge else meant to say about that. Relatively straightforward. I think the only real little gotcha there is with this, or little conveniences with this mod operation, if you've not seen it before, can be quite useful. And I think using a hash map basically to set up your tree is a very nice way to do it. I do that all the time in these problems, but if ever there's like a tree or a graph involved, I'm almost always jump to this data structure for it, because I find it just works very efficiently. And in Ruby, the syntax works very nicely, so that it's quite straightforward to write it and test it, and printing it out on screen if you need to debug is also quite nice as well. So right. On to part 2 then. Part 2, let's go down. So yeah, so you're going through your sandstorm, and and you're not much closer to escaping your wasteland. You've told your camel to follow instructions, but you're not making much progress, so you need to make significantly more steps. So then you make the leap that maybe the map isn't for people, but it's for ghosts. Oh god! And that the ghosts aren't bound by the laws of space time. Sure, why not? Why not? So what you determine is that there's a bunch of start points that all end with A. So we're not just interested in AAA anymore. Now we're interested in all of the start points that just end in A. So their example here is this 1A is one start point, and then we've got 22A down here, which is another start point. And what we're told is that now the endpoint is any node you get to that ends in Z. So we have here 11Z, and then we have down here 22Z. So those are the two endpoints that correspond to the two start points in this third example that he gives us. So this puzzle gives you something that's slightly misleading, but it is technically what you're going to be doing, but it misleads you, I think, into thinking how you should approach it, which is relatively typical about how a lot of these problems are phrased. But basically what he says is you need to start at each of those nodes simultaneously, because you're a ghost and you don't have to go by space and time, and you need to walk each path simultaneously to try and find the Zs. And what you determine is if you start at each of the start points and you keep taking the one step the same each time, you're following the same instruction each time, that you will at some point arrive with both of those paths you've walked reaching an endpoint at the same time. So one might reach an endpoint before the other, but then at some point, if you keep taking steps, you'll both be at an endpoint at the same time. So yeah, that's how they've kind of expanded the puzzle here. So they have the example here where you start on these 2 points, you move to the left because we're going L or in this example, so we go to the left. So that left gives us 2 points. Then you go to the right, and that gives us 2 points. So you'll notice here that we've reached a Z point, and then this other one hasn't reached a Z point yet. But we still, because one of them hasn't reached its Z point, we need to take another step. So we now go to the left again, which is back cycling our L and OR thing. And now you see that, well, we were on that Z point, but now we're back away from that Z point again. The other one's reached its Z point. And so basically we keep taking these steps back and forth, back and forth, back and forth, back and forth, until eventually they've synced up. And you can see here, they sync up after 6 steps where they both end up on these Z points. So there's basically a pattern here. So it's going 1-1-B, 1-1-Z, 1-1-B, 1-1-Z, 1-1-B, 1-1-Z. The other path goes 2-2-B, 2-2-C, 2-2-Z, and then it's 2-2-B, 2-2-C, 2-2-Z, right? So there's these like loops basically. So we need to figure out in our input, we need to process this, but you can imagine our input is a hell of a lot bigger than this. So that's kind of where the trick will come in. So your first instinct would be, well, let's just do this. As they say, we'll change our input. Instead of being a single value, we'll look at an array of values, and we'll do the same for each of them. But our break condition will now be, we'll just wait for all of them to be at an endpoint, and that'll be our answer. So if you do that, you will be in for a world of pain. So it'll take a very long time basically to get there, if you try to simulate the whole thing. So there is a quicker approach, which you will realize by the repeating nature of the patterns. That's really the trick that you need to see here. So I surmised that this might be the case when I looked at this, that the patterns always repeat. So there'll always be this looping, repeating pattern over and over again. And you have to, and that's where the trick for this problem is going to come in. So you don't actually have to do everything in parallel. You can do each one on its own, and you'll end up with a bunch of numbers. And then effectively those numbers will be the lengths of those repeating patterns. So they'll all sync up based on the lowest common multiple of the length of each one. And that's effectively the trick to the answer for this. So if we go and look at the code for that, part 2, nothing has really changed hugely, except I now am start initializing this list of nodes, which is, so before we were just always starting at AAA because we just had this one starting node. Now we'll have multiple starting nodes, so I'll initialize an array with them. And then in my parsing logic down here, I have an extra line which just pulls out each of those starting nodes as we've looped through our map and just stores them in an array. And then, yeah, down here, this is effectively the exact same loop to walk the trees, except I do it nested based on each individual node, and I'm storing, instead of just storing a value of the steps, I'm storing an array, which will be the count of each step per starting node. And then, yeah, the only other change down here is that the break condition is now that I just need to look for the last character. It needs to be Z, and that's it. So aside from that, everything's the exact same. We traverse the map in the same way. We do the same mods check to get the index for the next instruction. And yeah, we just loop through this the whole way. We count our steps. We add that to this overall list. And then at the very end, we'll end up with an array of all these different steps. And this is just a simple method which basically lets you calculate, in Ruby, just lets you calculate the lowest common multiple of an array of integers. And that's it. You can look into exactly how this reduce function works if you like. But yeah, that will give you the lowest common multiple of an array of integers. And that works. So if I run this on the input, which was sample 3, it gives us, oh, interesting. Huh, why did that break? Oh, sorry, wrong code. Part 2, there we go. Yeah, so 6, and runs very, very quickly. And then when I run it for my input, that's the right answer. And it ran in a, very small, not a fifth of a second, 20th of a second. So that's pretty cool. And you see here, so the answer is a very large number. So that is, if you were to just try and simulate this by doing them all in parallel, that's the amount of iterations of that entire loop you'd have to do to arrive at the answer, which is quite a lot. So yeah, that's kind of a fun one. It required making that mental leap that, first of all, you had to figure that the loop was always going to be a repeating pattern basically to get you there. And then you also had to then know that, well, sure, it's great, it's a repeating pattern, but that if you just calculate each of those and then got the lowest common multiple, that would mathematically work out as the correct number of steps. So yeah, it's kind of two sort of, one, based on the calculation, you needed to have a mental leap to know that was the right calculation that was going to make it work. And then also you had to determine that the loops were always going to be repeating patterns, and then this would work. So yeah, there is a definite, I'm assuming that this is the case for everyone. I don't know, I'm assuming this isn't just my input that has the same pattern. But there's very easily a different problem could have a slightly different pattern that it works out as, and in which case this approach wouldn't work at all. Just so happens that this kind of this sort of shortcut works because of the way this exact problem has been written. I can't imagine that this is just me that's gotten this input that works this way. If it is, that'd be pretty incredible, but I assume this is the general approach that he's been hoping that people would arrive at. Yeah, so I don't think of anything else to say about day 8. It was a nice fun one. Looking forward to day 9 tomorrow. I hope you guys enjoyed this. Thanks for watching, guys, and I'll see you all tomorrow.